So I've upgraded my design again. Now I've split the design so that we have several cascaded 8-bit adders. So we can have a look at, this is my main VHDL file. There's a clock signal that goes in as an input. There's a 8-bit bus for the LEDs and a signal to clear the device, which is mapped to this button here. So if I press that button, it will clear all of the adders, all of the counters that are in here. There are some signals to transfer data between the counters, and then finally a signal to transfer data to the LEDs, the bus, where the LEDs are. And there are 4 of these count 8 objects, and they are all 8-bit counters. The clocks are all mapped to the same clock object. The outputs are mapped so that the carry flag out from one is cascaded to the carry in of another. And for the first 8-bit adder, the carry in flag is always set to 1, so that it always adds 1 every cycle. So you can see the inputs and outputs cascaded here, and then the output, the final output. So for each of these 8-bit devices, the whole output word can be seen using this output object, and that's just mapped to clock div output, which is then mapped to the LEDs that you see here. So this is the highest order counter. It means it's a 32-bit counter, and each clock is divided down by 2 because the counter works on a 2 clock pulse per cycle process. And you can see that the behavior of this is just trivial. It just takes the clock div output signal and transfers it to the LED bus. We can have a look at the count 8 object as well. So you have the same port declarations as in the main VHD file. The A object is effectively the accumulator. The Z is effectively the half add output calculation. The C is the carry flags, and the state goes between 0 and 1, and it works on a 2-state cycle. So if we have a rising edge on the clock, if the clear bit is high, then the state is reset, everything is reset. If the clear bit is not high, then if the state is 0, the state becomes 1, and the first stage of the process occurs, in which Z takes the value of the half add, and then C takes the value of the carries, and the output carry flag is set using C7. And you'll notice before I had B here, so I could add A and effectively another signal B. Now I've changed it so I just take the carry flag, concatenate it with a load of zeros, and that is the number that I'm adding to. And then the second stage of the cycle is if the state is 1, then A takes back the value of Z and the state is reset. So the way it works is Z and C are the first bit of the addition process, and then to get the value back into A, there's a second stage. And this is similar to doing plus equals in a language such as C, because the bus where the data is stored for the input is also where the output goes. So that's A. And you can see that it's working, and I can press my reset button and I can reset the device, and it's a 25 megahertz clock, which is divided by 2 because this state flag goes between 0 and 1. So that's 12.5 megahertz. And then it's divided by 2 to the 24 before the first bit here is seen. So there we go. Hope you found that interesting.